Hello everyone, today we seeing the topic is process scheduling and in-depth looking of algorithm and their impact. First of all, introduction. The presentation provides a comprehensive understanding of process scheduling algorithms, examining the types, programming metrics and signification in operating system. Process scheduling is crucial for managing CPU efficiently. The algorithms can such as first come first serve, short job first, and round robin. We will explore how they impact system performances, resource utilization, and user experience. Next, overview of process scheduling. Definition of process scheduling is process scheduling is the method by which an operating system decides which process runs at a given time. It prioritized process to ensure efficiency and fair CPU uses. Important in operating system. Process scheduling is crucial for resource management, enabling multiple processes to share to the CPU, enhancing performance and optimization of system responsiveness. This is the importance of operating system. The first come first serve and short time first job that is contained in the this topic. Next of all, we seeing about the key objectives. The primary objectives of process scheduling include maximizing CPU utilization, minimize turnaround time, ensuring fairness among the process, and reducing the waiting time. The first come first serve has some features. Next of all, second topic is types of algorithms. Primitive versus non-primitive. Primitive and non-primitive can be seen in the topic. Primitive scheduling allows a process to be interrupted and resume later, while non-primitive scheduling runs the current process to the completion before switching. It means primitive is a interrupted resumed later. While the non-primitive is current process that can be completion before switching, that is known as primitive and non-primitive. It can be researched. And second one is priority scheduling. In priority scheduling, each process is assigned a priority, and the process which the highest priority gets CPU first time first. This method is effective for ensuring that critical tasks are completed properly, especially in a real-time systems. However, it can be lead to the starvation if lower priority process are consistently overlooked, as they may suffer long wait times. The migration of the issues, some systems impacted again, where the priority of process increases the longer they wait in the queue. Next of all, round robin. Round robin scheduling allocates a fixed time slice or quantum to each process in a circular order, ensuring that processors receive a equal opportunity to execute. This method is partially effectively in the multitasking environment where fairness is essential, as it provides any single process of monopolizing the CPU. If the time slice is too short, it leads the end user's content switching, reducing the overall system efficiency, finding the optimal quantum time. Next, algorithms performance. Turnaround time. Turnaround time. Total time taken from the submission of the process to its completion, serving as a key performance metric in process scheduling. It embassies waiting time, execution time, and any other delays experiences during the process and the life cycle, such as input and output operations or content switched. Next of all, waiting time. Waiting time is measured how long a process has been in the queue for waiting the CPU time. If significantly affected overall system performance and efficiency, since longer waiting times to lead the delays in process execution. Response time means it is interval between the summation of request in first response made by the systems. It plays a critical role in user satisfaction, especially interactive systems. Immediate feedback is essential. Fourth one is user cases. In user cases, real-time systems means requires the deadlines to meet. Task must be scheduling to ensure that critical operations are executed within strict time constraints to prevent failures. Batch processing. Batch processing refers to the systems that process large amounts of data collected over a period. Scheduling in such environments focused on optimization in the process to the batch jobs without the human interactions. Next of all, multitasking environments. In multitasking environments, multiprocess must share CPU resources efficiently. Effective scheduling algorithms ensures that tasks are handled concurrently, enhancing user satisfaction and system performance. Next of all, fifth one is challenges. Starvation occurs when low priority processes are perpetuated denied CPU time, resulting the uncorresponsiveness. Proper scheduling policies are essential to prevent that issues. Next of all, deadlock. Deadlock is a condition where two or more processes are unable to proceed because each is waiting for the other to release resources. Efficient scheduling can minimize the risk of deadline situations. Content switching overhead. In this topic, content switching is the process of storing and restoring the state of CPU so that multiple processes can share a single CPU. Frequent context switches introduced overhead, reducing system efficiency and performance. Okay, last we can see the conclusion. Understanding process scheduling, algorithms, and the performance matters is vital for optimizing systems efficiency. By addressing challenges like starvation and deadlocks, we can improve overall systems in